Okay, good afternoon.
Good afternoon.
Okay, so this would be our topic for today, okay? So we call this the variable stress analysis, okay? So yung mga nauna po natin na topics, okay, ang tawag po doon, those are all simple stresses, okay? So when we say simple stresses, you have their members under pure tension, compression, bending, and then you have their torsion, okay? So dun sa simple stresses, say for example, we have the machine member, okay, and then we load it with a tensile force, okay. So the load that we use there is at a definite amount. Say we have there 10 kips, okay. So the load that you applied, okay, it is at a specified value, okay, defined ang value, and at the same time it is only applied once, okay. So that is what is meant by the simple stress, okay. But then here we'll have now variable stress, meaning the load that we apply to the member, okay, would be varying, okay. So it can be 10, it can be 5, or say you would see that it would be equal to 20. So the load is repeatedly applied to the member, okay. So how do we design these members under variable stress, okay. So basically if you are to compare the two, okay, it would be more easy to design under simple stresses rather than this variable stress, okay. Pag simple stress po kasi, you can easily say that this load of 10 kips, this would be my basis in the design since it's the only force that is acting on the member. Not unlike if it is a variable stress, it is 5, 10, 20, then go back to 5, okay? So there are several forces that you apply to the member, okay? So the load varies. So where will you base your design? Will it be on the minimum, the maximum, the average value? So you really do not know, okay? So that is why it is more, okay, complicated to design a variable stress rather than that of a simple stress, okay. So for this topic, okay, under variable stresses, we'll have two analysis, okay. One would be without stress concentration, okay, and then the other one would be with stress concentration. Okay, so how does the two differs? Okay, yan. Say for example, this is our machine member, and then on the cross section of the member, you cannot see any surface discontinuity. So that is without the stress concentration. But then, if you could recall, we use the monoblock chairs on our classroom, wherein you would see that at the back, okay, you would see there several holes. Same thing doon mismo po sa upuan, you could see there yung holes, okay? So yung holes na yan, okay, that serves as a stress razor. Meaning, stress will be concentrated on those areas, making this area of the member weak. Okay, that failure would most likely to occur on this area. Okay, so sasabihin natin, why then we put, okay, these holes on those monoblock chairs? Okay, if it is a stress razor, so possible that cracks would start with those holes. Okay, so why do we still put on those holes on our design, okay? It is because it serves a purpose, okay? So that would be used for air circulation. So we all know that the plastics, okay? So mas mainit po yan sa katawan, okay? So they put in these holes para po para magkaroon ng air circulation so that yung pawis po hindi matitigil doon sa likodan natin, okay? So meaning these holes, these are part of the design, okay? So no way to eliminate them, okay? Kasi it serves a purpose, okay? It's part of the design. So what we need to do on our design is to consider, okay, to consider the stress razors And in the computation of our machine member, the dimension of the machine member, then that should be incorporated. Okay? So that is the one with the stress concentration. Okay? So we will be having our design based on these two. Okay? Without and with stress concentration. Okay? But then both are variable stresses. Okay? So how do we design these members? Okay? So when we say again variable, you subject the member to several loads. Okay? So to fluctuating loads or variable loads. Okay? With and without the stress razor. Now, how do we design this member? Okay? So kakalimutan muna po natin dito the usual design stresses that we have. Okay? For the simple stress, we have the design stress sigma D equal to sigma U over factor of safety o kaya naman po sigma Y over factor of safety. Same thing if you have there tau D, you use tau U over Fs or tau Y divided by factor of safety. Okay? So these are the usual design stresses that we have or that we use on our simple stresses. Okay? But then on variable stresses, hindi na po muna ito yung ating gagamitin. Okay? These are not the design stresses that we will be using on the variable stress. Okay? So ano po yung gagamitin natin as the design stress? Okay? On this variable stress analysis. Okay? We have this Soderberg, okay? And then the other one is the Goodman equation. Okay, so these are your design stresses for a variable stress. Okay, so we'll use the Soderberg and then the other one is the Goodman. Okay, so you simply choose among these two which will be used. Okay, so how do you know? The Goodman, this is good for brittle materials. Okay, so if you are given a brittle material, then you make use of the Goodman equation as your design stress. Okay, and if you have a ductile material, okay, you use now the Soderberg. Okay, again. So, on your design stress, you simply pick between or you simply choose between Soderberg and Goodman. Okay? So, how will you choose? It's basically doon po sa kanyang material. Okay? If it's ductile, you use the Soderberg. If it is brittle, you use the Goodman equation. Again, it is valid for variable stresses. Okay? Now, let us take a look at the Soderberg equation. Okay, so this is the Soderberg equation. Okay, so this one at saka po ito. Okay, these are both a Soderberg equation. If you notice, okay, the denominator that contains sigma y and tau y. Okay, of the first term. Okay, so sigma y and tau y, it is because it is a ductile material. So basing design on the yield strength. That is why we use this. Okay. On the other hand, for Goodman, okay, Goodman is used for brittle materials. So take a look at the equation for Goodman. Okay. So this is Goodman equation. So as with this one. Okay. Dito naman po ang ginamit natin is sigma u and yung tau u. Okay. Ultimate strength. Because it's the basis of a brittle material. Okay? So, if you are to compare the Soderberg and the Goodman equation, okay, the same lang po yung equation niya. Nag-iiba lang po, okay, the only difference is this sigma u and tau u. Okay? In a case of Goodman, this would be, in a case of Soderberg, this is sigma y and this is tau y. Okay? So, that's basically the difference lang po between the Soderberg and the Goodman equation. Okay? As you can see po, both Soderberg and Goodman has two forms, okay? So this one is in form of sigma, okay? And then the other one is in form of tau, okay? Let us see also that of a Soderberg. Okay, so for Soderberg, you have this. Okay, this is in form of sigma and another equation in form of tau. Again, you have to choose between the two. Okay, Soderberg and Goodman, it's basically based on the type of material, whether ductile or brittle. Okay, but then you have to choose also between sigma and tau. Okay, so where are you're gonna use the tau and yun pong sigma. Okay, so tau will be used if the member is subjected to shear. Okay, it is subjected to shear and also to torsion. Okay, so you will be using tau. Okay, but then if the member is subjected to tension, compression, bending, and also if it is thin wall, okay, you will be using sigma po. Okay, so sana po alam natin kung paano pipiliin. Okay, again, sigma will be used for tension, compression, bending, or thin wall. Okay, whereas yung pong tau natin would be used for shear and torsion. Okay, so dyan lang po tayo pipili, okay, between Soderberg and Goodman, and between sigma and tau. Okay, so that would be your design stresses. Okay, so let us take a look at the equations. Okay, so let us take a look at the equation. So this is your Soderberg equation, and then see the components of the equation. Okay, so the same component lang po siya with the Goodman. Okay, so let us go into details on the components. Okay, let us have the first one. We have the factor of safety. Okay, so for the factor of safety, this is usually given. Okay, the factor of safety is usually given. But if not, we'll have the factor of safety on the same table 1.1. Okay, so given or taken from table 1.1 for the factor of safety. We have there sigma y, and in the case of the Goodman, that would be sigma u. Where can you obtain this two? Adriel.
At by next week po ay ibabalik po during our
Table din po.
Okay, design table din po. Sigma y, sigma u, this would be taken from our design tables given the codes. Okay, the AISI and the SAE code of the material. So you can define or determine value of your sigma u and sigma y. Okay, what about tau y? How do you obtain the value of tau y?
How we deal with cotton.
Obtain the value of tau y.
Naman ng cosican.
Saan po natin yun pwede makita or makuha? Miss Irish. Miss Irish.
Anong integral ng cosican?
Miss Irish. Wala.
Anong integral ng
Yes po, ma'am. Nandito na po.
Oh, what is tau y?
Yung sa taway po ay 0.6 times po yung yield strength po natin.
So, tau y would be equal to 0.6 of sigma y. Okay? So, yun po yung natin na tau y. Okay? What about tau u? Alex?
0.75 po times ultimate strength.
Okay, so that would be 0.75 of sigma u. Okay, so we have known that po from our previous discussion. Okay, the value of the tau y and also the value of your again, this is 0.6 of sigma y and this is 0.75 of sigma u. Okay, so those are the values. Now, what is new to us would be yung sigma m, sigma a, and sigma n, and also yung tau equivalent niya, tau m, tau a, and tau n. Okay? So this is what is new to us. Okay? So let us go and discuss yung kung mga values po na yan. How do we obtain these values? Okay? So we start first with your sigma n, and your tau n. Okay, what are the values of these two? Okay, what is sigma n and tau n? Okay, so you find here, okay, sigma n and tau n, okay, as the endurance strength. Okay, so you have here the endurance strength. Okay, this is your sigma n. Okay, and then yung tau n po natin, this is called the endurance strength in shear. Okay, so these are the values of their sigma n and tau n. Okay, so to find this value, okay, they are dependent on what we call life. Okay, yung buhay. Okay, just like yung humans, okay, we have our life. Okay, so when we say life in terms of the material, okay, we have the so-called indefinite, and then the other one is definite. Okay, indefinite meaning walang hangganan. Okay, walang hangganan. Okay, walang katapusan. You can use the machine member, okay, all throughout. Okay, whereas this one naman, definite, it would mean simply that it can be used only up to its useful life. Okay, meaning say it's defined as 10,000 cycles. So ibig sabihin, at 10,000 cycles, you can have its maximum efficiency as it operates, as it functions. But then more than that number of cycles, it will not function as intended. Okay, o kumbaga, hindi na siya ganoon ka-efficient. Okay, it will not be that efficient. That is why they called it definite. Okay, so they said simply, okay, the life of the machine member. Okay, so that would be indefinite and definite. So how do you know if the problem calls for a design based on the indefinite life and based on a definite life? Okay, so how do you know? If you are given here number of cycles, okay, number of repetitions, okay, that would be the indicator that you are, okay, to design based on the definite life. Okay, yan po yung ating palatandaan. So here po, the life of the machine member is not by the number of years, like just like the human. Okay, so sa tao po, it is by the number of years, but then here for machine members, it's on the number of cycles or the number of repetitions, okay, as it functions. Okay, so these are the indicators. So if you see these phrases on the problem, that would mean you are to design based on the definite life. So kung wala naman po, meaning you are to design on the indefinite life basis. Okay? So, sana po maliwanag yun. Okay? So, how do we, okay, why is it important that you define the life of the material? Okay? You should know that when you decide its basis is indefinite or definite. It is because you have two sets of equations. Okay? You have a different equation noong para sa indefinite life versus that of a definite life. Okay? So, that is why it is important for you to know, okay, the basis of design. Okay? So, so that you can use the correct equation, okay, for the value of sigma n or tau n. Again, we call this sigma n as your endurance strength, and your tau n is endurance strength in shear. Okay, so let us have now the set of equations. Okay, so these are the equations for indefinite life and this one for the definite life. Okay, you try to compare now. Okay, you try to compare the equations for sigma n and tau n, that is dependent on the type of loading. So we have your axial, okay? Meaning tension o kaya po ay compression. Okay, it's axial. You have your bending, combined rotating and bending, and then you have your torsion. Okay, so same thing with the definite life. So you try to compare now. Okay, indefinite versus definite. Say for axial. Okay, so tingnan natin equation for axial indefinite, equation for axial definite. Okay, you try to compare one by one. Bending to bending, rotating bending to rotating bending of definite, torsion at indefinite, and torsion at definite life basis. Okay? Try to see the difference. Okay? What is the difference?
How?
What is the difference?
Anong splitting? Sabihin mo kung anong split ang gagawin.
Yes, Luigi.
Sa nakikita ko po is doon po sa magiging value ng endurance strength po.
Alin basically ang magkaiba. Okay, you look at the equation. Axial sa indefinite and axial sa definite. Okay? You compare the two. Which is different?
Yan ang po ang ating D.
Yung sigma prime n po pati po sigma n1.
Okay, correct. So, ito lang po yung pinagkaiba niya. Okay, this is the only difference. Sigma prime n for axial on indefinite, whereas for definite, okay, instead, it makes use of sigma n1. Okay, so all equations, yan lang po yung pinagkaiba. From sigma prime n of an indefinite life, you make use of sigma n1 for definite life. But then, the same equation na po. Okay? So, let us have the value of h. Okay? So, what would be the value of sigma n? Okay? And then, let us have the parameters for each of this equation. Okay? So, for axial, meaning tension or compression, sigma n is equal to 0.8 sigma prime n times the surface factor. So, that is the same with bending. So, same equation lang po siya. Okay? For rotating bending, you have the addition of a size factor. So, 0.8 sigma prime n, surface factor, then addition of a size factor. Okay? And for torsion, so this is the only equation for tau n. Okay? So this is the only equation for tau n in torsion. 0.6 sigma prime n, surface factor times the size factor. Okay? Now, and then if you are to compare this with that of a definite life, so same set of equations. Okay? Again, only your sigma prime n is replaced by sigma n1. Okay, but then all other parameters, the same na po. Okay, so same thing, this is your tau n. Only equation for tau n. Okay, so let us have each of this equation. Okay, so unahin po natin is sigma prime n. Okay, so what is this sigma prime n? Okay, so sigma prime n, okay, you call this your endurance limit. Okay? So, ito po lahat ng yon, okay? These are all your endurance limit. Sigma prime n. Okay? So, what is sigma prime n? Endurance limit, and it is dependent on the classification of material. Okay? So, what are those classifications? Wrought iron, okay, if wrought iron and BHN value less than 400, you use the equation sigma prime n equal to 0.5 of sigma u, or you may use sigma prime n equal to 0.25 of BHN. BHN is Brinell hardness number, okay? But if it's a wrought iron and BHN is greater than 400, then you use 0.4 of sigma u for your sigma prime n. Okay? If it is a cast steel, you use 0.4 of sigma u. If it's a cast iron, you use 0.35 of sigma U. For nodular, you use 0.4 of sigma U. And if normalized, you use 0.33 of sigma U. Okay? So meaning, you have to know first the classification of the material. Okay? So for example, you look at our design table. Okay? You look at the design table and have table 87. Okay? So table 87. You go to table 87. And okay, so on table 87, you would see there wrought iron, okay? You have there also wrought steel, okay? Wrought iron.
So, kapsa
Wait
po
lang.
na naintindihan po ito.
Okay, so you would see here wrought iron, wrought steel, and then below the wrought steel, you have the codes, okay? So meaning these are under that particular classification, okay? So from there, you would know their classification. Now, what if you do not know the classification? There are those tables that do not have the classification. In particular, we have table 88, okay? So wala po dyan na nakalagay na classification. Okay, alam mo C10 as 11, 17 as road. Okay, so wala siya particular classification. Okay, normalized, wala po tayong problema. We have the equation for sigma prime and for a normalized scale. Okay, but then for the others, wala po. Okay, and then also on the table, it does not include the classification of the material. Okay, so what you need to do is simply to see the BHN value. Okay, so you look at the BHN. Okay, is BHN less than 400 or is BHN greater than 400? Okay, BHN again refers to the Brinell hardness number. Okay, so that defines the strength and hardenability of your material. Okay, so if you have their BHN value less than 400, then how do you obtain sigma prime n? Okay, so you use 0.5 of sigma u. If it's greater than 400, you use 0.4 of sigma u. There are two equations here, one in terms of sigma u and the other one in terms of the BHN, 0.25 of BHN. But I would suggest that you make use of the first one. Okay, both can be used. However, it is advisable to use the first one. Why? Kasi po, if we are given the material, okay, mas malimit po ibigay is the value of the sigma u than this value of BHN. Okay? So on our tables po, okay, there are cases that yun pong atin na tables that must contain the BHN value. Say for example, we have table 8010. Okay? So no values of BHN is presented. Okay? So how can you obtain the value of your sigma prime n? Okay? If you will be using the second equation. Okay, so that is why I suggest that you make use of this. Okay, and then the other one, if BHN is not given, you assume to use, okay, sigma prime n equal to 0.4 of sigma u. Okay? So, yun po yung mga gagawin ninyo, okay, to obtain the value of the endurance limit sigma prime n. Again, let me reiterate first, okay, you look first for the classification, okay? Look at the design table, okay, if there is a particular classification of the codes given, okay? So, the second one, okay, the second one, if classification is not given, then you look for the BHN value. Okay? Then you apply this. If BHN less than 400, you use this sigma prime n 0.5 of sigma u. Okay? If it is greater than 400, you use 0.4 of sigma u. Okay, so that would be the second. The third one is no classification, no BHN value, so you simply assume, okay? You simply assume sigma prime n equal to 0.4 of sigma u. Okay? Why do we assume to use this value? Okay? If you are to look at the equations for endurance limit, okay, that is the most commonly used one, 0.4 of sigma u. Okay? So you can assume to use this value if the classification and the BHN value is not given. Okay? Maliwanag po ba? Hello?
Yes po.
Okay? So, I will not entertain questions relative to this during examination. Okay? That would simply mean na pag tinanong mo yan, okay, that would simply mean that you are not listening during our class. Okay? That is why you do not know these assumptions. Okay? On what sigma prime n you will be using. Okay? So, you pay attention. Okay? You should pay attention as to this rulings. Okay? So that you would know on what value you would be using on your computation on your design. Okay? So, that would be the value of your sigma prime. Again, you call it simply as the endurance limit. Okay? Then let us go back to the equation. Okay? So you have there 0.8 sigma prime n, and then the second will be surface factor. Okay? So all include the surface factor. Okay? So where can you obtain the value of the surface factor? Okay? So everybody, you look for figure AF5, okay, on our design table. Okay? You go to the design table and see figure AF5.
This could be one of the rules that you have learned. The product rule for derivatives.
Okay, that is on page 21. Okay, everyone, page 21. Yan, okay. So this is our, okay, figure AF5. Okay, so on figure AF5, this is where you'll obtain the value of your surface factor. Okay, so surface factor is taken from this figure. Okay, how do you use figure AF5? Okay, you look at the x-axis. Okay, so the x-axis that contains your sigma u. Okay, so given the material, okay, you look for the design table and then see what would be the value of your sigma u given the material. Say for example, you obtain their sigma u, for example, is 120 KSI. Okay, so you look here at 120, this is 120,000. Okay, so this line pertains to sigma u, okay, equal to 120 KSI. And then you look at the y-axis. Okay, so we have here two y-axis. Okay, ito at saka ito. Okay, so the y-axis, okay, on the right, okay, right side is the equivalent concentration factor. Okay, whereas the other one is percentage of endurance limit. Okay, so where is the surface factor? Saan po natin siya i-read? Okay, so dito po tayo kukuha the percentage of endurance limit expressed in percent. Okay, so dito po yung read natin on the left side ng figure po natin. Okay, so how is it used? So on the center, okay, of your figure, okay, written are different types of surfaces. Okay, so these are the types of surface. So you have the first one, okay, this is the curve. You have their mirror polish. Okay, meaning napaka-kinis, okay, okay nung kanyang surface. Okay, kasi mirror polish. Okay, so you imagine how ano po yung mirror natin, okay, how polished is our mirror. So yun po yung itsura niya. Okay, next would be ground polish. Okay, third would be machined, and then other conditions naka-indicate naman po dito on our figure. Okay, so Say for example, you are given sigma u equal to 120 KSI and then mirror polished. Okay? Mirror polished. So how would you take the value of the surface factor? So you have your 120 KSI and then dadalhin mo po on our okay, on our mirror polished, okay? So you have there now the point, okay? The intersection would be the point, and then you take its reading on the left, okay? So that's equivalent to 100%, okay? So yung 100% po natin, you take the decimal equivalent, okay? And that would be equal to 1. So this would be your surface factor, okay? So when we say the surface factor, we use the decimal equivalent, okay? Say you obtain 80%, okay? Nabasa mo po dito is 80%. So what would be the surface factor? That would be 0.80 or 0.2. Okay? So that is how you'll read the value. Now, what if the type of surface is not given, okay? So the type of surface is not mentioned, okay? So if it is not mentioned, you simply assume, okay? What do we assume? You assume machine, okay? Again, you assume machine if the type of surface is not given, okay? Assume machine, then have the reading at the left side, okay? Nakuha po ba? Hello?
Yes po, ma'am.
Yes po, ma'am.
So that is how you obtain the surface factor. You use figure AF5. Again, when you're using the value, you use the decimal equivalent. Okay? Yun po yung isa-substitute natin. In form of decimal, not in form of the percentage.
Challenge sa atin dito ay
Okay, so let me go back. Okay, so that would be the surface factor taken from figure AF5. Okay, the last one, you have there yung size. Okay, so for the size factor, okay, so for the size factor, you will be using 0.85. Okay, ito po yung gagamitin natin. On your initial solution, okay, you use a size factor equal to 0.85. Okay, so what does it mean? The size factor of 0.85, it simply means a range of 0.5 up to 2 inches. Okay, so meaning we are preempting that our answer, okay, our final answer will be on this range. Say for example, you are looking for the diameter, okay, then your answer, tingnan po natin if it conforms within this range. Say for example, get a diameter equal to 1.5 inches, okay, and then you compare this with the range, okay, so makikita po natin this is within the range, okay, so if this is within the range, meaning this size factor that we use, okay, tama po yun, okay? So this would be our final answer already, okay? 1.5 inches. Because it conforms with the size, okay? And also, okay, it conforms with yung pong atin na kinompute na dimension. Okay? What if naman po we obtain diameter equal to 2.5 inches? Okay? So, looking at the range, okay, this is not within the range. Therefore, the size factor that we use, the 0.85 na size factor is not correct in this case. Okay? Kasi we yield here 2.5 inches. Okay? So, what you need to do is to recompute. Okay? You recompute using size factor equal to 1.0. Okay? So, papalitan mo po ito. Magiging 1, then you need to recompute. And whatever diameter that you'll obtain or dimension that you obtain, that will be final. Okay? No need for assessing it again if it is within this range of 0.5 up to 2. Okay? Question. Nasundan po? For the size factor.
May ganyan sa inyong page 8, 9.
So, every time that you use the size factor, okay, you will always refer to your final answer, okay? You look at your final answer if it conforms this size range, okay? If it conforms, then you have a correct size factor. Then if not, then you need to recompute using a different size factor. Okay?
Let's go to Angeline Politano.
Nakuha po ba? Nasundan?
Yes po, ma'am.
Yes po.
Okay. So all of this, okay, all of this are to be substituted to your equation, okay, for you to be able to obtain sigma n and tau n. Okay? So isa-substitute po natin dito yung sigma prime n, yung surface factor, o kaya po kung included yung size factor, okay, to obtain sigma n and tau n. Okay? That is for an indefinite life. Okay? Now, what is the difference for the definite life? Instead of sigma prime n, you replace it with sigma n1. Okay? So, how do you obtain now sigma n1? Here is the equation for your sigma n1. Okay? This is sigma n1. Ari pong nakabox. Okay? So, again, how do you know if it is a definite life? If number of cycles are given or number of repetitions. So, endurance strength, you will be using sigma n1, okay, for your equation, okay? So, the equation involves sigma n1. And what is this equation? Antilog of the quantity, okay? Antilog of the quantity, log of 0.8 sigma u squared over sigma prime n, minus 1/3 log of 0.5 sigma 0.9. Hindi ko makita. Yeah. So, log of the quantity. Okay, so sigma n1, okay na po ba? Hello? Okay na?
Opo, ma'am.
Okay, so for the value of sigma n1, okay, this is the equation. Antilog of the quantity, log of 0.8 sigma u squared over sigma prime n minus 1/3 log of 0.9 sigma u over sigma prime n multiplied by log of NC. Okay? NC pertains to the number of cycles. Okay? If number of repetitions is given, yun din po yun. NC or NR. Okay? Number of repetitions. Okay? So, yun po yung NC. And then, here, you have their sigma prime n. Okay? Again, this is your endurance limit. Okay? Yung diniscuss natin kanina on the indefinite life. Okay? The same lang po ito. Okay? So, even though it's a definite life, you still need to determine sigma prime n. So, hindi po tayo doon nakaligtas. Okay? May sigma prime n pa rin pong involved po dito sa definite life. And then sigma u, of course, would be our ultimate strength. Okay? So, in order to simplify this, you need first to simplify the one inside the bracket. Okay? So, you simplify this first, and once you have a simplified form of this or the value for this, tsaka po natin i-antilog. Okay? What is antilog? So, on your calculator, that would be inverse log. Okay? Or it is shift log. Okay? So, you make sure you are
mamaya na ang blast
you
mo,
have your
kasi-
calculators with you. Okay? Make sure you have your calculators with you having these functions. Okay? Otherwise, you'll have a hard time, okay, computing for your sigma and 1. Okay? So, hindi muna po pwede din yung yung mga pangbigasan na calculator. Okay? Because they do not have the values of this log and antilog. Okay? So, hindi ko na rin po pwede ituro sa inyo, okay, kada isa, okay, kung paano ba yan pipindutin sa calculator, okay? You have your calculators, okay? Make sure you are you know how to use your calculator and where to find these functions on your calculator. Okay? So again, to simplify this, have this first, okay? Simplify the one inside the parentheses. Then afterwards, you take the antilog of your answer. Okay? So that gives you the value of your sigma n1. Okay?
X squared over 2 kaya magiging 1.
So, you look at the equation for sigma n1, medyo po yun, medyo mahaba yung equation natin. Okay? And then there is a shortcut version. Yan, you have this, the simple equation for sigma n1. You try to include this on your manual. Okay? You try to write this one. Okay? So, this is an equation also for sigma n1. Okay? So, both are sigma n1. So, you look at the small version. So, sigma n1, okay, this is sigma n1 equal to sigma prime n, then quantity 10 to the 6 over number of cycles raised to 0.09. Okay? So you can use this equation also for your sigma n1. So you have your equation 1 and this is your equation 2 for sigma n1. And that sigma n1, this is what you will be, the value would be substituted to this, okay, to obtain your endurance strength, sigma n or tau n, okay? So that is the value of your sigma n1, okay? Question is, which of these two equations, 1 or 2, will be used? Okay? Are we free to choose which of these two equations yung gagamitin po namin? Okay? O ano po yung sagot doon? Okay? O syempre pag pinapili po tayo, you will be choosing number 2 because this is less complicated than the other one. Tama po ba? Mas madali po itong gamitin compared to the first equation. Okay? Oh. So, which among these two will be used to obtain the value of your sigma n1? Okay? So, ano po yung sagot natin doon? Okay? Both. Okay? You use both. These two needs to be computed. Okay? So, parehas po natin na i-compute. Okay? Parehas po natin isosolve. Okay? You solve, okay, for sigma n1 using both equations. Okay? Again, you use both equations. Then you try to compare their answers. Okay? So, what is the answer using equation 1 and what is sigma n1 using equation 2. Okay? So, you need to solve both. Again, you need to compute for sigma n1 using equation 1. You solve again for sigma n1 using equation 2. Okay? Then you compare answers. Okay? You compare the answers and choose whichever is lower in value. Okay? Kung alin po yung mas maliit yung value between equations 1 and 2, then that is to be used. Okay? So you choose whichever is lower and that is to be used in solving for sigma n or tau n. Okay? So whichever is lower, okay, yun po yung gagamitin natin dito. Okay? Sigma n 1. Okay? Naintindihan po?
O yung logarithmic.
Hello?
Yes po. Yes po, ma'am.
Okay? So, hindi po tayo mamimili ha. Okay? You do not have to pick whether you use equation 1 or you equation 2. You have to solve both. Okay? And see which is lower to be used in solving for your sigma n and tau n. Okay? So that is how you obtain the value of sigma n and tau n. Again, you need to know first the life, whether it's indefinite or definite life basis. Okay? Question? Wala po? Okay? So let's go back. Okay? Let me go back again to your Soderberg or Goodman equation. Okay? So let me have here first the Goodman at saka Soderberg. Okay? This is the Goodman and Soderberg. We are done with sigma tau n. Okay? Oh, ano na lang po, yung sigma m, sigma a, tau m, and tau a. Okay? So what are those values? Okay? For sigma m, sigma a, tau m, and tau a. So this has something to do with the stresses on the material, okay, and with the loads that you apply. So let us simply recall, okay, yung equations natin for tension,
Order of choosing the U.
okay, compression, bending, okay, tension or compression, or say, yan po yung action, okay? What's our equation for the stress, tension, and compression? Sigma equal to force over the area, okay? Have here bending. What is our equation? Hello?
Ang ating pong letter I.
What is our equation for bending? Those are simple stresses. Yes, Carl.
Ang ating pong polynomial ay
MC over I po.
Okay, correct. Flexural stress is equal to MC over I. Okay, so that is our equation. If you have there thin wall,
kapag may mga keyboard at mga wayroad,
thin wall and then cylindrical. Okay, if it's cylinder, your sigma would be equal to P over 2P. And if it's vertical,
and for E, the exponential,
it is simply PD over 4P. O, total, 4. This is our equation.
Okay, so let's apply.
Anyone?
For
Question?
the given x sin x,
Hello?
the x ay polynomial.
Anyone po? O baliki yung notes po natin on torsion. What is the equation?
From left to right.
TC over I po.
And again, ADL,
TC over J po.
TC over J. So that is the general equation, TC over J. But then, we have derived already coming from yung solid and yung hollow shaft. Okay? Kapag po solid, tau of solid would be 16 T over pi d cube. Okay? For hollow, what is the value?
16 T capital D po over pi times capital D raised to 4 minus small d raised to 4.
Correct. Okay? 16 TD over pi times d to the fourth minus d to the fourth. Okay? So these are the equations that we use, okay, on our simple stresses. Okay? So same equation would be used for the variable stress. Okay? Lamang po, okay, sabi natin, the stress varies. Therefore, the loads that you apply to the member, that varies. Just like our first example po kanina, if you have there yung material natin subjected to a tensile load, okay? So the force here varies, okay? The force, say, initially at 5 kips, tapos it becomes 10, it it becomes, say, 15, and then naging 20, and then back to 5. So there are a lot, okay? Or there are several forces, okay, that applied. So the value changes that varies, okay? So which one would be used in our variable stress, okay? So gaano man po yung kadami, you simply choose the minimum value, okay? And also you choose the maximum value, okay? So kukunin lang po natin maximum and minimum values, okay? And yun po yung gagamitin natin, okay? So here po, the force here, okay, this one is varying, okay? So yung force, katulad po nito, can be 5, 10, 15, 20. But what we need only would be the 5, the minimum value, and the maximum value equal to 20, okay? So in our equation here, the stress, it is the force that varies, okay? It is the force that varies. Wait lang.
Of pronouncing, paano sila
So here in our equation, okay, it is the force that varies, okay? So doon po sa tension and compression, this one, okay, this, it is varying, okay? So you simply choose the F minimum and the F maximum. Okay? On bending naman po, it is the moment that varies. Okay? Wala. Hello? Narinig pa? Okay na? Ulit?
Yes po, ma'am.
Okay. So, on bending naman po, it is the moment that varies. So, if you are given several values of the moment, you simply look for M maximum and M minimum. Okay? Yan. For thin walled, it is the pressure that varies. Okay? So, for the pressure, okay, kunin lang po maximum pressure and minimum pressure. And then for torsion, is the torque. Okay? So, the torque varies. So, again, choose only the maximum and the minimum values, okay? The maximum and the minimum values, okay, of the forces, the pressure, the moment, and the torque, okay? This will be used in computing your sigma M and sigma A, tau M, and now, so how do we obtain the value of sigma M and sigma A? Okay, so when we say sigma M,
okay, let's now
this is the mean or average stress. Okay, the mean or the average. And when you say sigma A, that would be alternating or the range stress. Okay, so how do you obtain the value? Okay, for sigma M, that would be equal to what? As the average, so you take the average maximum plus the minimum value divided by 2. Okay, and for your sigma A, it would be the difference. Maximum minus minimum divided by. Okay? Question is, what is value of sigma max? Or what is the value of your sigma minimum? Okay? So you go back to our equation. Okay? This one, okay? Sigma equal to force over area if it is tension. Okay? So for example, if it's tension, ulit lang po ulit akong kulay
Wala pa.
Okay, so what would be the value of your sigma maximum and sigma minimum? Okay, where what would be the value of sigma max? Kung yan po ay tension or say compression, okay, the equation po natin is sigma equal to force over the area. If I want to obtain sigma maximum, then what is sigma maximum? You will be using maximum force. Okay? So F max over the area. Okay? If you want sigma minimum,
What we have
ito na
as
po
the
yun,
first part,
it would be F minimum divided by the area. So in our sample, which is F max, which is F min, okay? F minimum would be yung 5 and F max would be 20. Okay, so this would be 20 over A, and then this one would be 5 over A. Nakuha po ba? And from the area, that is where you'll obtain your dimension, okay? The unknown dimension. That is kapag tension or compression. Kapag po bending,
pagkahirap mo pang i-integral.
okay, what would be the equation for bending? Sigma equal to MC over I, okay? So I want here sigma maximum. So what would be sigma maximum? M max C over I. And what is sigma minimum? This is equal to M minimum C over I. Okay? Di ba sabi ko nga po sa inyo, hahanapin mo maximum minimum value. Okay? So, ganun din po. So, if you have their thin walled, what would be the equation? Sigma maximum would be P max DI over 2T. Sigma minimum would be P minimum DI over 2T in case it's a cylinder. Okay? In terms of tau naman po, okay, that would be torsion. Okay? So, for torsion, that is where you'll have your tau M. What is tau M? Tau max plus tau minimum divided by 2. Your tau A would be tau max minus tau minimum divided by 2. Okay? What would be the value of tau max and your tau min? Okay, what is the answer? What is tau max and what is tau min? For torsion, our equation is, say for example, it's solid. 16 T over pi d cube. So if I want here tau max, I'll be using here T max. And if I want tau minimum, then that it would be equal to what? 16 T minimum divided by pi d cube. Okay? So, this tau max and this tau min, yan po yung gagamitin natin dito. Okay? To obtain your tau M and tau A. So, ganun din po dun sa sigma kanina. Okay? So, that is how you obtain your value of tau M and tau A. Question? Hello?
So, dahil kompleto na
Nasundan po ba?
ang ating U, ang DP,
May tanong po kayo?
ang DU at V, so pwede na po natin gamitin
Hello?
ang integration by parts formula.
Oh, medyo madami po ito.
Wala naman po, ma'am.
Madami po ito equations, okay? That is why from time to time, I am asking you, okay, if nakukuha nyo ba yung sinasabi ko, okay? Kasi, ano po siya, madaming equations and need really to be addressed, okay? So, that would be give us the value of tau max. Yes, Miss Alisa?
Ma'am, bali po yung sa tau max and tau min po ay pwede po siya gamitin sa ano po sa min and alternating po or sa ano lang po sa alternating lang po.
Anong, hindi po, parehas po ito. Di po ba? Tau M is tau max plus tau min. So, what is tau max? This is the value and this is tau min. Okay? If you obtain naman po the difference, it will give you tau A. At the alternative. Okay? So, both po ito, okay? Ito yun, tau max and tau min. These are the equations, okay? That is on torsion. Yes po niya. Okay? So all of this, okay, that are to be substituted to your Soderberg or Goodman equation. Okay? So yan po yung mga isa-substitute po natin dito. Yan. Tau n, tau a, tau u, tau n. So all would be substituted to the Soderberg or the Goodman equation for you to obtain the diameter or the dimension. Okay? So, dun po natin, pag na-substitute mo po lahat, okay, you'll find there the dimension. Question, where in this equation of Soderberg and Goodman is your dimension? Nasaan po dyan yung dimension? At what particular parameter po on the equation? Nasaan po siya? Sigma M, sigma U, sigma Y, sigma A, sigma N, and so as yung sa tau. Saan po siya makikita? Hello? Hello? Saan po? O, di po ba on design, we are looking for the dimension. Okay? So, looking at the Soderberg and the Goodman, saan po dyan yung dimension po natin included?
Sa endurance po ba?
Sa?
Yan, may naka-thumbs up.
Hindi po dun tayo sa endurance. Kasi kung tinignan nyo po kanina, yung sa equation po ng endurance, it does not involve any dimension. Alin po yung nag-involve ng dimension? Yung area, yung mga diameter, okay? So, alin po ang meron noon? It would be your sigma A, sigma M, tau A. Okay, yan po yung value. Katulad po nito. This is our sample. You have here tau max is 16 T max over pi d cube. Tau min is 16 T minimum over pi d cube. So if you'll obtain tau M and tau A, so that would be in terms of the d cube. Okay? So yung dimension po natin, it would be on, okay, this tau M, tau A, sigma M, and sigma A. Okay, so dimensions are on those parameters po. Okay, sa mean or average and the alternating stress. For your sigma N, okay, sigma U, tau U, tau N, tau Y, sigma Y, okay? These are all numerical values and that does not contain po yung value ng dimension po natin. Okay? Alin lang yung may dimension? Yung po nandun sa numerator. Okay? Yung nandun lang sa numerator. Your sigma M, sigma A, tau M, and tau A. Okay? So, nandun po yung equations po natin. Now, let us have po the types of the induced stresses. Okay? Or types of the variable stresses. Kung may sulat. Okay, din na lang muna po. Okay? So, we have here the types of variable stresses.
Ang integral ng x squared ay x cubed divided by 3. Mamaya na plus.
Okay, so the first one, we call it reverse. Okay? So we call it a reverse stress. Ano po yung ibig sabihin ng reverse stress? Okay, halimbawa po, ito yung graph natin. Okay, so this is the maximum. This is sigma maximum, for example. This is sigma minimum, and this is 0. Okay, so we say that your sigma maximum is equal to negative sigma minimum. Okay, so for example, maximum is 10 kips or 10 KSI. Yung minimum is negative 10 KSI. So parehas yung value nila. Okay, only that the one is the negative of the other. Okay? So, sigma max equal to negative sigma minimum. Okay? So, if this is a property of the reverse stress, you find now the value of your sigma M. Okay? And value of your sigma A. So, what is the value of your sigma M? Well, you first have the general equation. Sigma M is maximum plus minimum
exponent
divided by 2. Okay, so that's the general equation. Now, for sigma maximum, palitan po natin siya ng negative sigma minimum. Okay, negative sigma minimum plus sigma minimum divided by 2. This will give value of equal to 1. So, ano pa?
and we are by
M
Ma'am Choppy po.
sa 0. Okay? So, sigma M is equal to 0. So, how do you arrive at this? Yung maximum po natin equal to negative sigma minimum. So, pinalit po natin, we substitute negative sigma minimum here. So, negative plus positive, that will yield 0. Okay? So, 0 over 2, 0 yung sigma M. Okay? Likewise, we derive for the value of your sigma A. Okay? So, what would be the value of sigma A? Maximum minus minimum divided by 2. Again, maximum is equivalent to negative sigma minimum minus sigma minimum divided by 2. Okay? Negative 2 sigma minimum divided by cancel this 2. What is left is sigma minimum. And what is negative sigma minimum equal to sigma equivalent to sigma maximum equal to your sigma A. Okay? So this is the property. Yes, Ken?
okay.
Okay na po, ma'am. Kanina po kasi wala pong nasulat po, ma'am. Pero okay na po. Salamat
Sigma
po.
A is equal to sigma max. So you have to know that these are properties of your reverse stress. Okay? So when it is mentioned on the problem, it's a reverse stress. So tandaan lang po natin, for a reverse stress, sigma M is 0. Your sigma A equals your sigma maximum. So, no need for you to start with the general equation. Okay? Hindi na natin kailangan ito. Okay? Ang kailangan na lang natin is sigma M is 0, sigma A equals your sigma maximum. Okay? If it is a reverse stress. Likewise, for tau M, that would be equal to 0 also. And your tau A would be equal to tau maximum. Okay? So, to derive this 2, okay, to derive this 2, palitan mo lang po ito lahat ng tau. Okay? Lahat ng sigma, okay, palitan po natin ng tau. Okay? So, in that case, you'll yield tau M is 0 and tau A equal to tau maximum. Again, to derive this 2, ito pa rin po. Same procedure is to be applied. Replace all sigma by tau. Okay? So, these are properties of your reverse stress. Okay? Second one. So the second one is called repeated stress.
Kung ilan po ang power ni algebra, ito po ang beses.
For a repeated stress, okay, it's either the maximum stress or the minimum stress is set to 0. Okay? Pwede po yung sigma maximum is 0 or sigma minimum is 0. Okay? So for example, we set sigma minimum to 0. Okay? We set sigma minimum to 0. So what would be the equation for your sigma M? Okay? So what would be the equation for sigma M? Again, you start with the general equation. Sigma M would be maximum plus minimum divided by 2. Okay? So sigma maximum, minimum is 0 divided by 2. So we yield sigma max over 2. Yan po yung sigma M. Okay? What about sigma A? Maximum minus minimum divided by 2. Again,
So, sa pangalawang
minimum
ulit
is 0.
ng
So,
integration
minus
by
0
part,
over 2.
naging simple
This would yield
formula
sigma
na ang
max
Yan, mapafinalize.
over 2 equal to your sigma A.
Don't forget to distribute
So what can you say now? These two, they are equal. Okay? So sigma M is equal to your sigma A if it is a
Okay?
repeated stress.
So again,
Both equal to sigma max divided by 2. So ito lang po yung tatandaan natin. Likewise, if you want the relation of tau, tau M would be equal to tau A equal to tau max divided by 2. That is, if you have a repeated stress. Okay? Question?
Ang gagamitin po natin,
And then the third one, okay? And then the third one, what is the third
ang
one?
power ng
That would be the
algebra.
fluctuating type. Okay?
O,
Fluctuating.
ngayon,
And for the fluctuating, you simply use the general equation. Okay? Sigma M is maximum plus minimum
prone to error.
divided by 2.
Meron
And your
po,
sigma A would be maximum minus minimum divided by
ang
2.
algebra.
Okay?
Multiply
For
by
tau,
sine.
the same equation po. Okay? Paltan lang po natin lahat ng tau po ilan. Okay? So, yung fluctuating, that's the general equation. Okay? And from that, we simply derive, okay, the equation for repeated and reverse stress. Okay, para pong ito, makikita nyo po dito sa sample problem na nandyan, okay? O, yun po, yung letter A. Torque is reverse. So, yan po yung reverse stress. Yung pangalawa po, torque varies from 0 to maximum. So, minimum is 0. So, therefore, yan po ay repeated. O, ano yung pangalawa? Torque varies from 2876 to maximum. So, meaning this is minimum to maximum. So, yan po yung fluctuating type. Okay?
Pag-perform ng
So, we have a lot of equations po involved in this variable stress analysis. Okay? So, your assignment before our tomorrow, okay, before our face-to-face meet is for you to review, okay, what we have discussed today. Okay? Para you have yung you know what equation would be used in solving for the problem. Okay? So, alalahanin po lahat. Okay? How do you obtain each component in the Soderberg and the Goodman equation? Okay? So to easily remember po the Goodman and yun pong atin na Soderberg equation, okay? We have here po a trick for you to easily remember the equation, okay? If there is a trick, mas most likely po na maano po natin, okay? Ma-recall natin yung equation, okay? So, yung Soderberg po, okay, the Soderberg equation
Kung hindi po natin i-perform ang tabular,
is known as
ilang beses tayong
yung pong Mayan. Okay, this is Mayan, whereas yung Goodman,
ilang beses
we use here mu1, okay? So, yun po yung para ma-easily recall po natin. So, alin po yung Mayan and alin yung mu1? For the Soderberg, 1 over Fs equal to sigma m over sigma y plus sigma a over sigma n. Likewise, you have that tau version. Tau m over tau y plus tau a over tau n. For the Goodman, 1 over Fs, sigma m over sigma u plus sigma a over sigma n, tapos yung tau version. So, okay, paki-include na lang po. Which is Mayan. Ito po yun. M, Y, A, N. Okay, that is Mayan. Okay, for the Soderberg, this is mu1. M, this is sigma u, okay? M, U, A, N. Okay? So, yan po yung ginagamit natin na indicator for us to easily recall the equation. Okay? So, this is Mayan. Okay? This is, ano ba yung sinulat ko? This is my N, okay?
Una for x.
And then the other one, this is new one, M-U-A-X, okay? For you to easily recall the equations. Okay? Question?
Stop na doon.
None?
Tapos,
Wala naman.
kung ilang
Okay, so I'll stop the presentation now.
derivative,
Okay, so make sure review, okay, the procedure, the equations involved before our sample problem discussion tomorrow. Okay, so open your camera. Let's have
integral niya ay negative uli. Integral
our
ay
attendance
positive
check.
and then katapat ng 0. Integral pa uli may negative uli.
Okay, Alex, Rio.
Nakuha po. Process.
Ano po, ma'am?
Okay.
Oh.
Game na po.
And then,
1, 2, 3.
you have copied the U and then multiplied by the V. Ay, alin sa ang V ng V?
1, 2, 3.
Yung nasa lower na negative.
Okay, thank you, Neng.
So,
Salamat.
gawa ka
I'll see you
ng
tomorrow. Bye.
diagonal down.
Thank you po, ma'am.